In this section, we're going to start talking about simplifying radical expressions. For instance, a radical expression is an expression with a square root. So if I were to take the square root of 9, in this section, we're just going to be talking about the principal root because that's what this symbol means. It means the principal root. The principal root is only the, in terms of square roots, it's only the positive answer. So the principal root of 9 is just positive 3. In the past, we looked at problems where we introduced a plus or minus root of a number, and we would get plus or minus 3. If you don't have this plus or minus, and you're not actually introducing the square root to the problem, you look at the problem, it's only a square root, we're only looking for the principal root. That's what this symbol means. So unless you see a problem with a plus or minus out in front of it, we're only looking for the principal, not both of them. Okay? So there's a rule that we have to follow. It's called the property of radicals. If we have a problem set up in this form, or an expression, and I'm going to write it out twice, so we can talk of two different instances. Okay? The first instance, we're going to say n is even. If n is even, and we're taking the nth root of a number 2 in the nth power, then the answer is going to be the absolute value of x. If n is odd, then we don't need the absolute value. It's just x. And the reason, let's look at an example, then we'll take a look at why that is. If I take the square root, and I don't really need the square there, it's understood to be a square root, but I'm going to write it just for the sake of this problem, of 9 squared. Well, not 9 squared, x squared. Okay? So we want to keep it a variable. So if I take the square root of x squared, if these two numbers are even, then my answer is going to be the absolute value of x. If I said we're taking the cube root of x cubed, then the answer would just be x, not the absolute value of x. And let's put a number in there so we can see why that is. Now if I take, now let's put that 9 back in. So I have the square root of 9 squared. Now if I take 9 squared, or any number squared, the answer is always going to be positive. So if I take 9 squared, it's 81. If I take negative 9 squared, it's also 81. So if I'm taking the principal root, let's take the square root of 81. If I'm taking the principal root of that number, I'm only looking for the principal root, it's going to be positive 9. That's why we only want the absolute value of x, so just the even answer. However, if we look over here to this cube root, so I have the cube root of, let's say, negative 2 cubed. Well, if I take negative 2 cubed, we get negative 8. So it's possible to get a negative number here if we're taking a number to an odd exponent. So your answer would be negative 2, because it's very easily, that could very easily happen. So we don't need just the absolute value. We need the number itself. Okay, so that's the difference in that property of radicals definition. If n is even, we're looking for the absolute value of the variable. If n is odd, we're just looking for the variable itself.